So today we're going to start chapter 6. We'll cover section 1. Today we're going to learn about perpendicular and angle bisectors. So let's go ahead and define what a perpendicular bisector is. And again, we already saw this back in chapter 3. So now we're seeing it again. So a perpendicular bisector could be a segment, it could be a ray, a line, or a plane that is going to be perpendicular to a segment at its midpoint. So what needs to be bisected is going to be a segment. Now here you can see that CP in this picture is the perpendicular bisector of segment AB. And again, what you can be looking for when you're looking at a diagram to tell if it's a perpendicular bisector or not is it needs to have the right angle, and then you would need to look for the two congruency marks on either side of that perpendicular bisector because it's going to split it into two congruent pieces. Now, before we see the next theorem, we need to understand the definition of the word equidistant. And what that means is it's going to be the same distance. Or if you sort of look at the word, it sort of looks like it's spelling equal, or you could also say that it's an equal distance. So we needed to understand this term before we see the next theorem. So now we have the perpendicular bisector theorem, and what this states is in a plane, if a point lies on the perpendicular bisector of a segment, then the point is equidistant, here's that word, from the endpoints of the segment. So notice here, it says if CP is the perpendicular bisector of AB, then that will tell me that AC or CA is going to be congruent to CB. So any point that is on this perpendicular bisector here will be equidistant from the endpoints of the segment it bisects. Now, let's say I added another point on my bisector. Let's say I add in point D down here. And then I draw segments connecting the endpoints of the segment that CP bisected. Because of the perpendicular bisector, I could tell that segment AD is going to be congruent to BD because point D is on that perpendicular bisector. So any point that is on the perpendicular bisector is going to be equidistant from the endpoints of the segment it bisects. So the converse of the perpendicular bisector, again, remember this is when it's a converse, it switches the order, the if and the then switches. So here now it states that in a plane, if a point is equidistant from the endpoints of the segment, then it is on the perpendicular bisector of the segment. So notice here, it's telling us that if DA is equal or even congruent, you could also have a congruent symbol here, then point D lies on the perpendicular bisector. So notice this line, it's a line, notice the arrow, so this indicates that really it keeps on going, and point D is on that perpendicular bisector, and notice point D has segments that are connecting the endpoints, and notice that they are both congruent. So from this picture, I could make several statements. I could say that point C lies on the perpendicular bisector of AB, and then what I could do is I could draw in the congruent segments to the endpoints since C is on that perpendicular bisector. Now that I've extended the line, I could also state that D lies on the perpendicular bisector because of the congruent segments to the endpoints. So I could also say D lies on the perpendicular bisector of AB. These are all statements I could make based on the diagram. I could also say that point P lies on the perpendicular bisector, because notice, again, the congruency marks to the endpoints. So P also lies on the perpendicular bisector of AB. So all of the points listed there are on that perpendicular bisector, because notice they are all equidistant from the endpoints. And then another statement I could make is that CP, or even CD, is the perpendicular bisector of AB, because it's got the right angle and it's got the congruency marks. Our first example, using the perpendicular bisector, notice they've stated that BD is the perpendicular bisector of AC, and they want us to find the length of AD. So since they're telling us BD is the perpendicular bisector of AC, I know that that is going to have a right angle here, and it splits AC into two congruent pieces. But what I need to know or use is that I now know that since BD is the perpendicular bisector, then point D is going to be equidistant from the endpoints of AC. So this is going to be congruent to this. So CD is going to be congruent to AD. So I can go ahead and say that AD is congruent to CD, and then I'm going to go ahead and replace what AD is equal to, which is 5x. CD is going to be equal to 3x plus 14. And now I can solve for x by subtracting 3x. And I get 2x equals 14. Divide by 2, and x equals 7. Now, remember, just like on the quiz, and on the test, you should remember, go back and see what they're asking us to find. And I know it's kind of dark here, but they want us to find the length of AD. And AD was right here, it was 5x. So now I'm going to replace what I just found x to be equal to, and that's 7. So the length of AD is going to be 35. Now, if you wanted to double check it, CD should also be 35. So you could also take what CD equals and plug in 7 to the 3x plus 14. 3 times 7 plus 14. So 3 times 7 is 21 plus 14. And notice CD is also 35. Now, it didn't ask for CD, but that would have been a way that I could double check that I did get the same answers. Because again, remember, CD and AD are congruent segments, because D is on that perpendicular bisector, so I know it's equidistant from the endpoints of that segment that was bisected. The next one is still, it says we're using the perpendicular bisector theorems. However, for 1 and 2, I'm going to use the theorems. And for example 3 here on example 2, or part 3, I'm going to be using the converse. So notice here it says that ZX is the perpendicular bisector of WY. So remember, when something has been bisected, it's going to split it into two congruent pieces. So that tells me that WX is going to be congruent to XY. And then they're also giving me the length of YZ, and YZ is 13.75. And they want me to find the length of WZ. Well, since they told me that ZX was the perpendicular bisector, I now know that point Z is equidistant from the endpoints here of WY, so that tells me that ZW is going to be congruent to ZY. So if ZY is 13.75, so is ZW, or WZ. So the answer to this first one is going to be 13.75. I didn't have to do any calculations. So this was using the perpendicular bisector. And again, remember, if a point lies on the perpendicular bisector, then it's going to be equidistant from the endpoints. Then for number 2, again, same information. ZX is the perpendicular bisector of WY. But this time, they're going to give me WZ as an expression, not just a number. And same thing for YZ, it's an expression. I'm going to do exactly the same thing. I know that they're congruent, but now I have to solve an algebraic equation. So this time, and I'll do this in a different color, I'll do it in blue now. So number 2, the information is in blue. So here, it's telling me that WZ is going to be 4n minus 13. Now, I'm not using the 13.75 anymore. This is a new question, but I'm just doing it in a different color so you can see it. And then YZ is n plus 17. And again, I know that since point Z is on that perpendicular bisector, I know that WZ is congruent to YZ. So to solve this, I'm going to go ahead and I am going to set them equal to each other, combine my like terms, and solve for x. So for number 2, I'm going to be setting 4n minus 13 equal to n plus 17. I'm going to combine my like terms by subtracting n from both sides. I'm going to add 13. And now I get 3n is equal to 30. I'm going to divide by 3. And n equals 10. Now, it didn't ask for n. It asked me to find the length of YZ. And remember, YZ was n plus 17. So now I need to go back and plug in 10 for my n, add them, and I get 27. So the length of YZ is going to be 27, which would also make WZ 27 as well. Now we're going to do number 3, and I'm going to be using the converse for this one. So notice on this one, they gave us the length of WZ. I'll do this one in purple. So WZ, now I'm using the number WZ to have a length of 20.5. And WY is going to be 14.8, and WY is down here, and it's 14.8. And then YZ is 20.5. So notice they are giving me the fact that the two segments are equidistant. So since WZ and YZ are equal, then I know that Z is on that perpendicular bisector, and I can tell that it is a perpendicular bisector. So to find the length of WX, I'm going to take the length of WY and divide it by 2. So I know for part 3 here that 2 times WX, or WX, sorry, equals 14.8. And then here I can divide by 2, and WX is going to equal 7.4. Because remember, this segment here was bisected, so it makes it into 2 congruent pieces. So really all I needed to do was divide 14.8 by 2 to get the length of WX, which would also be the length of XY. So again, because those two segments were congruent and that WY and ZX are perpendicular, then I know that ZX is that perpendicular bisector and that segment WY was split into two congruent pieces. So this answer here, WX, is equal to 7.4. Next, we're talking about an angle bisector theorem. So if a point is on a bisector of an angle, then it's going to be equidistant from the two sides of the angle. So again, equidistant means same distance. Remember the distance, whenever we refer to a distance, it always has to be the perpendicular segment. So we need to look for that right angle. If you were that lesson where we talked about the equal distance, remember I said you're on the banks of the river and here's the water and you want to swim across and you're standing here and you want to get across that river because it's full of alligators, but you want to get across it the fastest way, you're always going to swim the perpendicular distance. You would not want to swim diagonally here. So remember, the distance is always going to be indicated with a right angle because it has to be the perpendicular segment. So again, what we're looking for here, the equidistant, we would be looking for congruency marks on these segments as well. The next slide has the converse of the angle bisector theorem. And again, remember we switched the if and the then. So this one says if a point is in the interior of an angle and is equidistant from the sides of an angle, then it lies on the bisector of the angle. So again, we're going to be looking for those congruency marks on the distances as well as the right angle. And then as soon as we can see that, then we know that this angle here, BAC, has been bisected, and then we can also conclude that we have congruency marks here. So for example 3, it wants us to find the value of x. Notice the angle here, and I know it doesn't have letters, but this angle, notice, has been bisected because it's been split into two congruent angle measures. So that tells me that those two segments that are on that angle bisector are going to be congruent. They're going to be equal distance from the sides of the angle. So this tells me that x is also going to be 15. And what we just used to figure this out, that x equals 15, is the angle bisector theorem. So for the angle bisector theorem, if you notice an angle has been bisected and then you have segments that are drawn to the sides of that angle that was bisected, then you know those segments are going to be congruent. The next example is going to use the converse of the angle bisector theorem. And notice this time we're given that the segments or the distances from that angle bisector to the sides of the angle are congruent. So that tells me that the angle was bisected. So that tells me that this angle, 3x plus 5, is going to be congruent to 4x minus 6. So to find the value of x, I need to set these two equal to each other. And I'm going to set 3x. So 4x minus 6 is equal to 3x plus 5. I'm going to go ahead and combine my like terms by subtracting 3x. X minus 6 equals 5. Add the 6. And x equals 11. So by looking at these two congruency marks, that this point here is equidistant to the sides of the angle, that tells me that that angle up here was bisected. And that is the converse of the angle bisector. So here again, it wants us to find the value of x. Notice that this angle here has been bisected. Notice the two congruency marks here indicating that this segment or this ray here is the angle bisector. So because I can tell that that angle has been bisected, then I know that this point here on this angle bisector is going to be equidistant to the sides of the angle. So this segment 5x is going to be congruent to the 6x minus 5. They're both equidistant to the sides of the angle that was bisected. So again, I'm going to set up my equation to solve. I'm going to be doing 6x minus 5 equals 5x. Doesn't matter which one you put on the left or the right. And then now what I can do is solve for x. I'm going to go ahead and move the 6x over. And I get negative 5 equals negative 1x. I don't want to have a negative x, so I divide by negative 1. 5 equals x. So x, and I can flip it around, equals 5. If it asks you to go back and find the length, let's say I added in letters here. Let's say I said this was A, B, C, D. Let's say they asked me to find the length of AB. If they asked me to find AB, then I would have had to take 5x and plug in 5, multiply, and the length of AB would be 25. So on the quiz next week, just make sure you read. Does it just want you to find x, or does it want you to find the length of a segment, or even the measure of an angle? Now, the next example, we actually did this in section 3.5. This was that very long problem. So we did this in 3.5. This was the very long problem you did in the homework, and we also did it in the notes. And I had told you, oh, you will not have to do this in chapter 3's test, but it's going to come back. And here it is again in chapter 6. So remember, this has multiple steps in order to get the equation of the perpendicular bisector. So I'm going to walk you through nice and slow, step by step. It's going to take us 4 steps. So the first step is going to be, you should be graphing these 2 ordered pairs and connecting the points. Well, if you notice, PQ was already graphed for me. And I've also graphed the perpendicular bisector. However, on your homework and maybe on your quiz or your test, it won't be graphed for you. You're going to have to figure out what the graph looks like. So technically, step number 1 would be to graph the ordered pairs of P and Q and create that segment. Next, we need to find the midpoint of PQ. And we're going to call that midpoint M, which is what's already in the picture. We're going to find the midpoint M of segment PQ. Because remember, that's where the perpendicular bisector needs to go through. Needs to hit the midpoint of the segment that's being bisected. And remember, your midpoint formula is to add the x's, divide by 2, and add the y's of the ordered pairs and divide by 2. So the 2 ordered pairs I'm using, P again is 2, negative 2, 3, and Q is 4, 1. So I'm going to add my x's. So the midpoint ordered pair, negative 2 plus 4, divide by 2, 3 plus 1, divide by 2. So the midpoint is going to be the ordered pair. I'm going to get 2 over 2, 4 over 2, which is going to simplify to 1, 2. And notice that's what's graphed for you. Next, I need to find the slope of the perpendicular bisector. So step number 3 will be to find the slope of the perpendicular bisector. So we're finding the slope of PQ. And remember your slope formula, you subtract the y's, and then on the numerator and subtract the x's in the denominator. So same two order pairs. So I'm going to do 1 minus 3 over 4 minus negative 2. And then I get negative 2 over 6, which simplifies to negative 1/3. Now, remember, that's the slope of PQ, but the slope of the perpendicular bisector is going to be opposite reciprocal. So remember, because the slopes of perpendicular lines are opposite reciprocals, the slope of the perpendicular bisector is going to be positive 3. I'm switching it to the opposite sign of the slope we just calculated and the reciprocal. Now we can write the equation. We have the slope and we have the midpoint. And actually this is part of 3 still. So number 4 is going to be to write the equation. So we're going to write an equation for the perpendicular bisector. And this is what the question had asked. So we know that the slope M of the perpendicular bisector equals 3. And we're going to be using the midpoint that we calculated, 1, 2. Remember, this is going to be the x and the y that we're going to plug in to y equals mx plus b. So I'm going to take y equals mx plus b. I'm going to replace the m with the 3. I'm going to replace the x with the 1. I'm going to replace the y. So I'm going to replace y and the y equals mx plus b with 2. Remember, you need to find the b first, then you're going to plug everything back in again. So let me plug in the 3 numbers. So I'm going to replace y with 2, my m with 3, my x with 1, and then I'm leaving the b because that's what I'm solving for. So I end up getting 2 is equal to 3 plus b, subtract the 3, and negative 1 equals b. This is the y-intercept of my perpendicular bisector. So now I need to take y equals mx plus b again and plug in the 3 for the slope and the negative 1 that I just calculated for my y-intercept. My equation of the perpendicular bisector is the equation y equals 3x minus 1. And again, that is the red line that was graphed. Notice the y-intercept is at negative 1, and it has a rise and a run of 3/1. So again, we already did this type of question back in chapter 3. It's now coming back to us in chapter 6. And that is it for section 6.1's notes.